You're walking down the lumber aisle at the hardware store, and honestly, everything looks exactly the same, just stack after stack of flat beige sheets. But look at what happens when you grab the wrong one for a bathroom vanity. That pristine, painted surface doesn't matter when invisible moisture seeps into a core that wasn't built to handle it. It swells, it warps, and the whole piece cracks apart. Every successful DIY build comes down to a specific balance. You are constantly weighing structural integrity and moisture defense against how much a board costs and how easy it is to cut. So we aren't ranking these materials from best to worst. We're looking at a strict matrix. Your job is to match the specific engineering of a board to the exact physical demands of your room. In construction, when we say boards, we're talking about flat sheets of material engineered to cover large surface areas quickly. Think walls, floors, ceilings, and furniture. Look at the sheer scale of these lumber yards. These stacks of varied flat lumber and boards are the foundational skin of almost every building you've ever stepped inside. They exist to do three very specific jobs: make structures strong, keep surfaces smooth, and make the final finish look neat. But physics dictates that no single material can perfectly achieve all three of those goals at the same time. A board that is incredibly strong is rarely perfectly smooth, which is why manufacturers had to develop highly specialized boards for distinct use cases. Let's start with the heavyweights, the structural and furniture category. If you're building a cabinet or a bookshelf, you're immediately going to hit the classic debate: plywood versus MDF. Plywood is engineered by taking very thin, physical layers of real wood and gluing them together tightly. This animation shows exactly why that matters. By alternating the grain direction of those glued layers, the wood creates exceptional core strength that physically resists cracking, even when you place a heavy load right in the middle of it. MDF, or medium-density fiberboard, takes a completely different approach. Instead of intact wood layers, MDF is made entirely of fine wood fibers, basically sawdust, pressed together with resin. Because it lacks those continuous layers of wood grain, it doesn't have the raw, load-bearing strength of plywood. Look at the wall cabinets and desk space in this photo. MDF's fine, compressed fibers yield a perfectly smooth surface without any wood grain. That makes it incredibly easy to shape with a router and flawless to paint. This gives us a strict rule for furniture construction. Spend your budget on plywood for the hidden, load-bearing frames that need to hold weight, but utilize MDF for the cosmetic pieces, like cabinet doors and decorative shelves. Once your structural support is handled, you can move to materials where weight-bearing capacity is irrelevant, and the focus shifts entirely to surface finish and saving money. First are laminated boards. These are standard board cores covered with a smooth plastic or decorative outer surface. You can see the sleek, uniform surfaces on these retro kitchen cabinet doors and countertops. That pre-finished plastic layer is vital for high-use, messy areas because it makes the surface totally non-porous and incredibly easy to wipe clean. Then you have the ultimate budget saver, hardboard. Like MDF, it's made from pressed wood fibers to be smooth and hard, but it is engineered to be extremely thin and exceptionally cheap. Hardboard provides absolutely zero structural weight-bearing capacity. You only use it as a lightweight physical barrier. Things like the bottoms of drawers or the thin backings tacked onto cupboards just to keep dust out. Smart renovators actively lower their overall project costs by aggressively using hardboard and laminated boards in these specific areas, spaces that require visual coverage or a cleanable surface, but absolutely no heavy lifting. But inside the walls of a house, weight-bearing isn't the only threat. You have to defend against the environment, which requires composite boards made of foam, gypsum, and cement. Watch how these panels function inside a dark wall cavity. This is plastic foam board. It is structurally useless, but thermally essential. Its sole purpose is to act as lightweight insulation tucked inside walls and ceiling panels, physically blocking cold air and keeping the building's temperature regulated. Right in front of that insulation, forming the visible interior of the room, is gypsum wallboard, what we commonly call drywall. Drywall is the absolute gold standard for interior house walls and ceilings because it goes up fast, it's cheap, and it takes mud and paint perfectly to create a seamless, smooth finish. But drywall has a severe weakness. Its paper and gypsum core acts like a sponge, making it highly vulnerable to moisture. That means for wet zones, you need a mandatory upgrade, cement board. Because it is forged directly from cement and strong fibers, it is virtually immune to water. In bathrooms or anywhere behind tile, the environment dictates the material. If you try to substitute standard drywall for cement board just to save a few dollars, you are guaranteeing rot inside your walls. Let's consolidate this into a practical strategy for your next trip to the hardware store. This diagram shows a spatial approach to choosing your boards. You always start by defining the environment first. If your path goes into a high moisture zone, like a shower surround, your decision tree stops immediately at cement board. If you are building floor sublayers or a load-bearing frame, you follow the high-weight path directly to plywood. And if your needs are strictly dry and cosmetic, like smooth shaping for custom shelves or just a cheap dust barrier for the back of a cabinet, you branch out to MDF and hardboard. By forcing yourself to ask, "What does this room demand?" before you ask, "What does this board cost?" you completely eliminate the structural risk of your project failing. So, the golden rule for keeping your budget intact is to save your money by using hardboard and MDF exactly where structure doesn't matter. And the golden rule for durability is to never compromise. Pay for plywood when you need strength, and pay for cement board when you need water defense. The next time you walk into the lumber aisle, you have the exact specs needed to engineer a permanent solution.